we'll go over this fluid or smoke solver together. So I have this smoke simulation being baked. It just has a few grids, a density, heat, color, divergence, pressure, and velocity. And I can use my viewer to view the velocity. This background is the noise I have turned on here. I have the divergence, I have the pressure, and I have the heat, and I have the custom, which is this vector type, and the grid name is color, which is being advected from the surface of my meshes. They also have a vector attribute named color, which is being advected. All you have to do is just specify your attribute. It supports floats and colors, just like this. So I'm taking the velocity, density, and heat from the surface. This is always taken. So your surface needs to have heat and density, and the velocity gets calculated by the movement of the mesh. And this is how my color looks. So if I turn off the viewer and go to render mode, so this is how it looks. It looks much better in render mode. And if you scrub more, and let's see, this is how it looks. If I go to the shader, I have my color connected to the emission, and if I have the color connected to the color as well, this is how it would look. If I turned off this completely, this is how it would look. If I connected this fire color, this is how it would look. Perhaps it needs to be more red. It depends on your taste. Okay, let's keep those connected like so. And let's go back to our geometry nodes. Now I am going to remove this bake just so we can see how the solver works. So I will delete this bake. It will take a while. I baked this at a 128 voxel amount. Okay, it's taking its sweet time. Okay, so currently it's taking, okay, this is 32 voxel amount, and you have some settings you can change. I can set the heat to 0, for example. This will make the smoke like a cold fog. It should move down because the environment temperature is internally set to 25. So if you set the smoke to something colder, like -100, it should move down. So like fog. And maybe I'll remove the color for now. This should speed things up. Okay, so what settings do we have here? Maybe I'll also remove the noise. So in your emitter, you can add multiple emitters like this. Just use a combine bundle, and you can combine multiple sources. Each source, you can use a mesh. In this case, I'm using a collection of multiple objects. And each one of these objects, like for example this plane, it has some custom attributes like this color I'm using, and I can set the heat. If I set this to 0, it will take the heat already stored on the mesh and the emitted density, and I can also specify a custom attribute to be advected. For example, if I capital V for vector, and I have a color with capital C, color, and now I have a new grid named color in the being outputted, and I can view it right here. So if I set this to custom, it will view the color, and the color is being advected with the inputted heat and density. So let's set this back to the default, which is 1000. This way you can input multiple sources to your simulation. Let's go back to density view. What this does is remove all the maps and keep the one you're selected, so Blender will automatically select it for viewing. If you don't remove this, if I want to view heat, I can't view the heat because Blender always views the first grid, and it will always view the density. So you can either sort them and put the heat up top, or you can just remove everything and keep the map you're interested in the viewer. Okay, so in the settings we first have the domain. You just put an object and it will take the bounding box of that object, and that will be your domain. So if I add a cube, okay, let me scale this down. So this is my cube, and if you go to viewport, I will set this to be wires. Let's go back to smoke and put my cube over here. So my domain is now this cube. If I go to edit mode, this cube is my domain. I can remove this. It will by default use 2 meters by 2 meters cube right at the origin. And next we have the solver resolution. You can pick from amount or size. If you set this to size, you can control the voxel size. If you set this to amount, you can control the voxel amount. I wanted to make it 3, like you can control the voxel amount on the X, Y, and Z, but the advection node I use to advect the velocity and some attribute does not support. You may not. It needs to be 32 by 32 by 32. You can't have like 32 by 16 or like 32 by 1. You can't have something like that. And the time scale, where you can control the speed of your simulation. The pressure iterations are for the pressure solve. Okay, we have the density dissipation. Let's set this to 0.2. It will dissipate a lot faster. You see, you'll even reach the top. You set this to this. It will dissipate a lot less. And we have the weight multiplier, which is the weight of the smoke. As you know, the smoke contains particles. So if we set this to 0.1, it will be heavier, and thus when it gets colder, we set this to 50, it will drop faster. So the smoke goes up, and when the heat gets colder, it will come down because it's a heavy smoke. We set this to 1, it should go down faster, as you can see. But let's just set this to default. The velocity, where you can control the velocity advection method. You can also control the velocity limiter and the velocity dissipation. Right now set to 0.5. Let's set this back to default. The heat, you have the heat dissipation. we have the buoyancy coefficient. This controls how much the heat lifts the smoke up, and the ambient temperature. This will get compared with the temperature. So if the temperature is above the ambient temperature, the more difference between these two, the more buoyancy power the heat will exert on the smoke. Next, we have the noise. So turning this on will add noise, and let's see it better with 64, and let's keep this playing for a few frames. So this is my noise. I can of course control the power. Set this to 0.25 for example. So now it's less effective. See? And if I turn it off completely, we'll get a uniform smoke like this. Okay. Next we have the custom grids. We can control the advection method for the custom grids, like the color one, and we can also control the limiter. We can add extra grids to be advected. Now you may be wondering how you can add extra grids. You can add extra grids by controlling a closure over here. So if I want to add an extra grid presim, all I do is drag, go closure, and if I view over here, this is presim. So I have my base grid, pressure, and now I can add a new grid. So we go store named grid, and let's get named grid, and all this is pre-simulation. So I'll get my base, and I will use this to field to grid. I'll use this but not remove it. So now I have a new grid. Let's just name it test, and let's get the distance, maybe not this. I'll add the position, and let's get the length, and add vector math. Let's set this to length, and I will map range this from 0 to 0.5. Let's get this over here. So this is my new grid, and we need it to be from 1 to 0. Okay, and maybe I will multiply this by 5, and maybe 0.1 meters, 0.25. So I've added a new test grid, and it's a float grid. I added it before the simulation, and now in my custom grids I can add f-test, and it should be advected. So if I go back here and go to custom, what is it saying? That's okay. So it's being advected with the velocity. My custom grid. Now supported grid with the given name. What is this? Oh, it's this one. So f-test. Okay, but I'm viewing it. Maybe my viewer needs a bit of an update, but it's working for the most parts, so we'll skip this. Anyway, let's remove our custom effect, and you can custom effect pre-simulation, post-simulation, or in the simulation initialize, or before pressure solve and after the pressure solve. So that's all about how to use the solver. Now we'll get inside the solver. So it's saying there's no grid named F test. So we'll remove that and also remove it from over here. Okay, now let's get inside the solver itself. So we have a few nodes over here. So we first set the bounds of our simulation, then we initialize some grids. Then this is just for the custom effects, you can ignore that. This is our noise, and here we advect the velocity, then we deal with heat and density, and the colliders are still a work in progress. The divergence step, we just take the divergence of the velocity using the provided node. Thank you very much. And next is the pressure solve. We solve the pressure pretty standard way. We'll go over that in detail later. And lastly, we update the velocity, and this is just so it gets divided by the grid size or the voxel size. And another custom effect, you can ignore that. And then we advect the custom grids like the color with the velocity. So this advects float grids and this advects vector grids. We get the names that are stored on the geometry over here. We'll go over that later. And lastly, we remove the base grid, and this is our debugging setup. We went over the arrow setup, and this is our viewer, and this just to sort the grids, so reorder. So Blender plays only the first one, which is currently the divergence. I'm just sorting them, so the density is the first one, so it always gets viewed even if you don't have a viewer. Okay, now let's go over each node. So set the bounds. We take the bounding box of the input mesh. There's no input mesh. We put our own cube, so 2 meters by 2 meters. We get the bounding box of it, and then we make a grid topology, and we set the resolution by either dividing the size by the voxel size. So the size of the cube gets divided by 0.1, for example, to make 10 voxels, or you can just say I want 10 voxels, and you make a grid, and I'm naming it base over here, and I am deleting the mesh so we can see what's going on. Next we have the initialization step. I don't need these. We take our base grid and use its topology to make and initialize some grids. So we have the density, heat, pressure, and divergence, and the velocity. Next, we initialize the grids that are coming from our colliders. So let's view that, or our emitters. So I have the emitter mesh, which is I only have one emitter, and this list is only one, and I am getting the geometry of that emitter, and on that geometry I have all the information I need. So we take the, for example, the source initialized vector, and inside it we get the bundle that is with our mesh. So for example, this Suzanne, it has a float attribute and a vector attribute, two lists, and we go over only the vector attributes, and here we go over only the float attributes. So the vector attributes, it has two vector attributes, which are the velocity and color, and we initialize them. So we initialize the grid, and we store the grid name so we can advect it later. So we initialize, and then we store the name back as a bundle. This is in the advection step. This is just for the initialize, and we do the same thing for the vector, and we multiply the attribute by this near emitter node. And how this works is we first take our mesh, and then we set it to volume. Just hide my emitters, distribute points in volume, and then we set the point radius to be the voxel distance. So this point radius is exactly matching its distance from its nearest grid neighbor, and we get the distance. If the distance is less than the radius, that means the voxel is inside our emitter, and we take the attribute. Okay, so it's initializing and storing, so not just initializing, and we also store the names under the float dash so we can advect them later. And that's all for the initialization step. The custom effect is just a closure, so you can add logic in here from outside your node. Next is the swirl or the noise. So we take the velocity, get its topology, and using that topology we can turn our noise texture to a grid and get the curl of this grid, so we don't have any compression or expansion areas, so it doesn't affect our divergence. And we scale that by the time scale, and we scale that just a personal preference by 2 because the effect looks good, and I can multiply it by 1, and we can control the speed and the details and the scale of our noise. This will multiply everything outside our simulation bounds by 0. So this is our top and bottom voxels, this is our left and right most voxels, this is our front and back most voxels, and everything that does not get multiplied by 1, and everything that is our border gets multiplied by 0. So that's all for the noise. This is just a custom closure. So next we advect the velocity. So we take the velocity and advect the velocity using the velocity, and we also multiply every border voxel by 0, and we multiply by the dissipation. Okay, and that's our velocity. And this is where the magic happens, where we add stuff to the simulation. So in this step, so we take our source, so it's the emitter mesh, and we loop for each source, and let's say this is my first source, and probably we don't need this node, or we don't need this node, and inside this we're going to take our attributes, our vector attributes that we want to carry to the simulation. So there are a few that we always want to carry, which are the velocity, the color is this just the custom one, and this is the same node. So we just take our source, we convert mesh to density grid, and we take this density grid and we multiply it by the attribute. So we have the velocity of our moving object right over here, and we have where our object is. We multiply the two, we get the velocity, and that on these voxels. So these voxels are inside our emitter, and they get the velocity. Okay, and next is the density. So in the float category we have the density and heat. We also loop over them, and we use the same logic. We don't need this node, not even this. So we take the nearest, we convert. So this is the nearest, I guess, heat. Okay, this is the nearest heat. We multiply by our density, and maybe I need to convert this to a boolean. Well, it is, so greater than 0, and we sample the grid and set this to be our multiplier. So we add this density or this heat. So the next iteration will go and add the density, and that's all for our addition. Next up, our heat and density dissipation. So the heat, this is the dissipation, so we just multiply the heat by some value each frame. This needs to be multiplied by the delta time, but I'm not gonna bother. Next up is our heat effect on velocity. As you all know, hot stuff or hot gases go up, so we take the heat, we subtract the ambient temperature, and we multiply by the buoyancy coefficient. Next, we subtract the weight of the density. So smoke with dust particles will have more weight, and thus it will be less affected by the heat. That's what's going on over here. We multiply by the time step. This is just so I noticed that sometimes there are errors and the smoke goes up so fast that the velocity advection or the advection step or the advection node can't keep up with it, so we lose density. So I capped it, and we multiply all that by a up vector and add it to the velocity, and this is just the density dissipation. We also multiply by a value. Next is our pre-solved closure, the colliders. I don't know how to implement those. I tested a few stuff and frankly nothing worked. Next we have the divergence. So we take the velocity and use this beautiful divergence node, and we multiply it by the grid voxel size and store it in the divergence. Okay, I may not need to do that, but that what worked for me. Next is the pressure solve. So this one is just sample grid index, and we take the voxel index and we add to each one. So this is the, I would say, the right, this is the left voxel, this is the front, this is the back voxel, depending on how you look at it, but this is the up voxel and this is the down voxel, and you add all of them and you subtract the divergence and you divide by 6 and you store the pressure, and you do that a few times. I do that 16 times in this case. Next we update the velocity with the pressure, so you get the pressure gradient and you scale that by the voxel size and you subtract it from the velocity, so no pressure areas. Next is our post solve custom effect, and last step is attribute advection. So let's just skip this for now. We have our attributes which are stored, so these ones. So they are stored in this way as paths, and then we get all the paths. So we have a float density. This one just removes the repetition. So we have F density, F heat, V color, and V velocity. And here we select only the flows and we replace the F. So we just take the attributes. So this is a list. And also here we have a list. We take only the vectors. I found out that storing them as a bundle and using this get nested path will remove the unnecessary stuff we stored in this step. And all we do is use an advect grid, and we use the velocity to get the named grid and advect it. Same goes for the vector grids. And how we store the names, we store them in this step. So over here and in here. So each iteration it will take the attribute and add F and this symbol after it, and it will get the bundle item. If the bundle item exists, it will skip. If it doesn't exist, it will store a bundle item with the path and the item being the same, and store it on the geometry bundle. So we end up with a get geometry bundle. When we get the bundle will have all these. So we have a V bundle and an F bundle, and each one, so get bundle item, and we want to get maybe a bundle, and its name is V. Let's test this. Okay, so the velocity bundle contains these, and the vector bundle and the float bundle contains these, and that's what we do the logic on. So we store those here, and then we advect them over here by just taking the floats and the vectors. I didn't add booleans because why bother. Okay, next step. So we have the post simulation custom effect, and we remove the base grid because we no longer need it. We have our debug arrows, so we just take the bounding box, we take our simulation, we get the bounding box, we also get a density grid, we distribute points, and we instance some points, and we sample the nearest grid, which is by default the vector. We align the instances, and then we realize, and that would be it. Next up we have our viewer. So when you select the density, this one will become inactive, so it will not be removed, and all the rest of the stuff will be removed, so keeping only the density, and thus you view the density. And this is for the reordering. Like we said, we'll make the density first, so Blender views it by default. Okay, and that would be all for the solver. If you have any questions, any things you want to add, Maybe later I'll add you can emit from points, so you can make like explosions and stuff like that. You can also take the attributes. I guess it would work if I just add points over here, but no, I'm using the volume of the mesh. Maybe I need to adjust the logic of the solver. Okay. Okay, that would be all for the solver. Collisions are still under development, so I can develop those. I tested a few things, but nothing really worked. And see you all on the next one. Goodbye. Oh, and I almost forgot. You can find the blend file for free on my Gumroad, link in the description. Okay, for real now. Bye bye.